Hello everybody and welcome to another video of Python playlist. In this video we are going to talk about various methods which we can use in list. Now some of the methods are very specific to list, which could be only performed with list data type, but others may be applicable for different data types like string, dictionary, sets and tuples. Now this is a continuation from previous two videos on list, so in case you haven't watched those videos, you can find those links in the description, or you can simply click on the I button on the top right corner and you can find the links from there. Now I have written down the code already and commented it out, as we are going to discuss more than 20 methods and list operations, and we don't want to waste your precious time by doing just some typing work in here. So without delaying any further, let's get started with the content of our video. The first method that we are going to talk about is append. Now this is a method which is used to add element at the end of the list. Now the element could be anything that you could think of, that is, it could be a list, it could be a dictionary, set, tuples, integer, float, boolean value, anything. So the syntax is basically the list where you want to append the value, the method that is append method, and the value that you want to add in here. So we are basically printing the values, that is print L before append and after append, to see how it is different. Let's try to run this. And there we go. As you can see, the last element, that is 24132, got appended at the end of the list. Now another thing to notice, the time complexity of append method is constant, that is O of 1. The next method that we are going to talk about in here is clear. So clear is a method that is used to remove all the elements from the list. Now here I have taken an example of various mixtures, that is of string, that is of boolean, that is of integer. Now I'm printing the value of list before applying the clear method, and the syntax is basically l.clear. That is a method you are going to call, and we are printing the list after the method. So let's check it how it looks. And there we go. This is the list before clear method, but after when we apply the clear method, all the elements get removed and this is just an empty list. Now the time complexity for this particular thing is O of n, because it is going to traverse through all the elements that is present in the list, and it is going to remove all the elements one by one. So that is happening in the backend of clear function. So the overall time complexity is O of n, where n is the length of the list. Now talking about the third method, that is copy. I believe the name itself is one of a definition, that is, it is going to copy the list into a separate variable. Now without using the copy method also, you could copy the list using this way, that is L copy equal to L. But one of the issue with this is, whenever you are trying to do any edit inside L underscore copy variable, the same thing will be applied over to the original list. So to prevent that, we could use the copy method, where our original list is going to stay intact and the changes will only happen with the L copy variable. So let's try to test this, whether it's working fine. And there we go, it is working absolutely fine. Now the time complexity for copy is O of n again, because it is going to traverse through all the elements and it is going to make a copy of that and assign it to L copy. Hopping on to the next method, that is method 4, that is the name count. So I believe you have already assumed that it is going to count something, and that's absolutely true. So what this is going to count is the occurrence of the value that we are going to pass in here. It could be a string, it could be an integer, it could be anything. So it is basically going to check how many occurrences of 2 is present in this whole list. So let's try to test this, and there we go, it is 4. So let's try to confirm it, that is 1, 2, 3 and 4. So there are 4 elements of 2. Now you guys could try to change with value that doesn't exist in the list and check what is happening. Now do let me know in the comment section what is the behavior if you are putting a value that is not present in the list. Now the time complexity for this is again O of n time complexity, as it is going to traverse through the full list to check whether the element is present at last element or is it present ever or not. Now talking about the fifth method, that is extend in here, you guys must have already assumed it is going to extend something. Now the formal definition of extend is basically adding elements of an iterable, that is, it could be a list, it could be a tuple, it could be a set, etc. at the end of a list. Now for this example, we are going to take L1 and L2, that is to a list, and we are going to perform extend on L1 list. So here we are going to do L1.extend and the list that we want to extend in here, and let's try to print L1 and L2 to see what the behavior is. So let's do this, and there we go. as you can see, the L1 list gets appended by all the values that is present inside L2 list. So this is what the extend method does. So whenever you are trying to do list1 dot extend list2, the list1 is going to be modified and all the elements of list2 is going to be appended in the list1. So the time complexity for this particular method is O of k, where k is length of the list that needs to be added. Now if you think logically, that seems valid, because from this point of time it is going, that is from end of list L1, it is going to append a length of k, that is here it is 6. So it is going to append 6 different elements. So this is why the time complexity here is O of k. Now talking about the sixth method, that is index. So you guys must have already thought this has something to do with the index of the element, and you guys are absolutely correct. So index method is going to return the index of first occurrence of the specified element in the list. Suppose we want to find the index of element 4 in here. Now you can see there are 4 places where the element 4 occurs. So we are going to get the index of the first occurrence of the element 4 that is specified inside this index value. So the syntax is basically the list from where you want to search dot index and the element you want to find the index of, and it is going to return the index. So you have to store it in a value or variable I, and you have to print it out. So let's test this once. And there we go, it is returning 4 in here. So the time complexity of this method is O of n, as in worst case scenario the element that you are searching might not be even present in the list. So in that case it is going to iterate the whole list and it is going to return it is not present in the list. So talking about the seventh method, that is insert. So this method is going to insert the element in a specified position. So how is this different from the append method? Now with the help of append, we are going to add the element at the end of the list only. But with the help of insert method, you could add the element at any position you want. So the syntax is pretty simple. It is the list where you want to insert the element, and the insert method. 4 is basically the index where you want to enter the value, and here the second parameter is the value that you want to add. So to distinguish, I have written a string in here, so it is easily identifiable inside this particular terminal, and there you go. So at the fourth index, that is 0, 1, 2, 3 and 4, you can find the element A is present in here. So the time complexity for this particular case is O of n again, because it has to iterate over to the position that we want to insert in. So in the worst case scenario, you could give the position as the end of the list. So here it is going to iterate throughout the list, and at the end it is going to insert the value. Now talking about the next method, that is pop in here. So there are two versions of pop that we are going to talk about. So here L is the list, and pop is basically a method which is going to remove the element. So here when you are doing L.pop of 3, it is going to pop the element that is present at index 3. But in case you are not specifying anything inside the pop method, as it is not mandatory, it is going to pop the end element. So let's try to test this. And there we go. So this is the list before pop. This is the list after pop happens at operation, that is index 3. So you can see at index position 3, the element 3 is getting removed in here. And at the end, we are not giving any argument in here. So it is basically removing the end element. So what is the time complexity of this? So the time complexity is O of 1 if we don't pass any parameter, as the pop operation happens through end of the list. But in case we are passing any parameter, suppose, so it could go up to O of n, as if you are passing the element of index 0, it is going to iterate from the end of the list until it reaches the position 0, and then it is going to remove the element from here. So the worst time complexity is O of n, but if we are not specifying anything inside pop as parameter, the best could be O of 1 time complexity. So talking about the ninth method, that is remove. Again, this method is also going to remove an element from the list. So what is the difference with the eighth method, that is pop and remove? So pop method is going to remove the element from the end of the list, or it is going to remove the element that we have specified as the parameter, that is index. But in case of remove method, it is going to remove or delete the first occurrence of the element that we are trying to remove in here. And the second difference is, if you try to store the value of L.pop of 3 in a variable x, you are going to get the value that is present at index 3, or the index that we are specifying. But in case of a remove, if you are trying to store the value in x, then when you are printing x in here, you are going to get none, because there is nothing that is returned when we are running the remove method. So the syntax is pretty simple, that is L dot remove of the element that we want to remove. So the expectation in here is it is going to remove 1 from the list that is present at the 0th index, but the element that is present at 2nd index is going to be untouched. So let's test this, and there we go. So as you can see, before 1 was present, but after remove operation, the first occurrence, that is at the 0th index, the element is getting deleted, but the 2nd index, that was now currently the 1st index, the value 1 is still intact. Now talking about the time complexity, it is going to be of O of n, as we are going to traverse throughout the list until we reach the element. Now talking about the 10th method, that is reverse in here, as the name suggests, it is going to reverse the order of the list, and that's the definition of it. So here we are going to take this example L in here, and we are going to print the L before reverse operation and after reverse operation. So the method is pretty simple, that is L dot reverse with parentheses, and it is going to reverse the order of the list. So let's try to run this and test this out. And there we go. You can see the original list is getting printed at the first line, but the reverse list is going to getting printed at the second line. So you could try to map this out, that is 45, then 2, then 5, then 4, then 2, then 4, then 6, and there that goes on. So you guys could probably match and check whether that's happening or not. And the time complexity for this is again going to be O of n, as it is going to traverse through the full list. Now the 11th method that we are going to talk in here is sort, and as the name suggests, it is going to sort the list. Now by default it is going to sort in ascending order, but in case you want to sort it in descending order, you might have to provide with extra parameters, that is reverse as true. Now we will dig deep into sort method in a separate video so that we could cover all parameters that is present, but now we are just going to talk about the method. So here the way is very simple, that is L dot sort, and there we go, it is just simply sorting the method. And let's test this out. And there we go. So the largest element being 45, it is getting printed at the last, and 6 is the second largest, 5 the third, 4 being the fourth largest, and the series goes on. So you guys could verify this. Now talking about the time complexity, it is O of n log n. I repeat, it is not O of n, it is O of n log n, and this is performed using the algorithm called time sort algorithm. So you guys could dig deep into time sort. I will provide the documentation to that so that you guys could check what time sort algorithm is and where this is specified. Now talking about the next method, that is in keyword in here. So let's check what does this do. So in keyword is basically confirming if the element is present inside the list or not. So to do that, we are just doing 1 in L, 47 in L. Now you can see 1 is already present in the list, so we expect it to return true. But in case of here, 47 is not present in the list, so it should return false. So let's try to test this out. And there we go, it is printing true and false. Now the time complexity is again O of n, as it is going to traverse throughout the list to check whether the element exists or not. So in case of 47, it is basically traversing throughout the list, and at the end it is returning false as the element is not present in the list. Now talking about the next method, that is del in here. Now del stands for delete. So how is it different from the two methods that we read, that is pop and remove? So del has the capability of deleting an element at a particular index, or a slice from a list, or the whole list. So how is it done? So you are supposed to write del keyword, and you have to specify the index that you want to delete. So let's try to run this. And there we go. At index number 2 earlier 1 was present, but now after deleting 1 has been removed. So let's try to delete a particular slice. So we have to provide the slice in here, that is from 2 to 5, and let's try to run this. And there we go. You can see the element at index 2, 3 and 4 are removed. So in case you want to delete the whole list, you just have to remove the indexing at all, and if you run it, you are getting an error. So why are we getting this error? So at line number 75 we are declaring the variable, but at line number 76 we are deleting that variable. So for the interpreter, at line number 77 L does not exist, and that's why we are getting this particular error that L is not defined. So talking about the time complexity in here, it is O of n time complexity, because if you pay attention to here, suppose we are deleting the first index, that is 0th index. So if you remember, we are supposed to shift the whole list by index 1. That is, we have to subtract one index from all the list. So for that, the time complexity is O of n in here. Now, talking about the next method, that is len in here. Len is one of the most common yet most important keyword that you will find getting used in any of the programming languages, because len basically returns the length of the list or the iterable that we are passing in it. So the syntax of it is len of the iterable that you want to calculate length of, and there we go, and it's going to store the value that is the length of the list. Let's test this out, and yeah, there we go. You guys could count from 1 to 15 if it exists or not. Now, talking about the time complexity in here, it is consuming O of 1 time complexity, because the length of the iterable is stored as an attribute, and it only takes O of 1 time complexity to get the value and return it to us. Now, talking about the next method, that is reversed in here. So you guys must be wondering what is the difference between a reverse and a reverse operator. So reverse basically was returning the reverse of the whole list, but in case of reverse, it is going to return the reverse iterator. So the time complexity for returning a reverse iterator is basically O of 1, but traversing throughout the list depends on the size, so it is going to be considered as O of n time complexity. So let's try to run this once. And there we go. When we are printing Z in here, that is reversed of L, it is returning a list reverse iterator object. But in case when we are converting the Z into a list, we could see the reverse of the original list is visible in here. So talking about the 16th method, that is sorted in here. So you guys must be already wondering what is the difference between sort and sorted. Now let me tell you, it is not a difference in time complexity, as both of them are taking O of n log n time complexity. So what is the difference? So in case of sort method, it is changing the original list and sorting it out in ascending direction. But in case of sorted method, this doesn't change the original sequence, whereas it returns another new sequence that is getting stored in variable Z in here without altering anything in the original list. So let's try to print this out, and there we go. You can see this is exactly returning the same thing that returned in case of sort method. Now, any and all are two different methods. These are not so common, but yet it could be important in various situations. Let's try to talk about the method any in here. So what is the definition of any? Any basically returns a boolean value that is true if any element in the list is true. So let's try to run this particular thing, and I will explain you with this example. So you can see in the first thing, there are various elements present. That's why it is returning a true in here. In case of the second one, that is the empty list, you can see no element is present. That's why it is returning a false. In case of the third, we are returning true, 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 false. So it is returning true in here because the condition is a single element has to be true minimum. But in case of the fourth example, we are checking everyone to false. So that's the reason it is returning false at the end. So the time complexity of this is again O of n, as it has to traverse throughout the list to check whether any one of the value is true. Now talking about the next method, which is not so common but might be important method, that is all in here. So this is the example we are taking, that is the same example from here. Now talking about the definition of all, it returns a boolean value true if all the elements of the list are true. Now this stands true in case of empty list also. Let's try to run this, and there we go. As I said earlier, these are the numerical values, so it is returning true. This is the empty list, and as I mentioned in the definition, empty item or list also returns true in here. So it is returning true. In the third case, it is true, true, true and false, and since there is one occurrence of false, the whole thing turns into a false. It is similar to AND gate. And in the fourth case also, since it is a list of false, it is going to return false. Now talking about the time complexity, it is again same as any, that is O of n, as it has to traverse throughout the array to check out which value is true and which one of the following is false. So talking about the next method, that is sum in here, as the name suggests, it basically returns the sum of all elements present in the list. So in this case, L is basically a list of integers, and here we are storing the sum at a variable n in here, as this returns the value. And the syntax is pretty simple, that is sum of the iterator, that is list L in here, and we're printing out the value. Let's try to test this out, and there we go, we are getting 91 in here. Now I have a question for you guys. As you can see on the screen, there is a list of strings that is present, that is A, B, C, D, E. And if you remember from one of the explanation, I told you that we could concatenate the strings using the plus symbol. So what do you think is going to happen if we are going to store sum of L, that is sum of strings, in a variable X and try to print it out. Let me know in the comment section what you guys think, or if you have experimented it already, then let me know in the comment section about the answer and I will surely reply it to you guys. Now talking about the time complexity, it is going to be of O of n time complexity, as it is going to traverse throughout the list to do the summation of all the elements that exist in here. Hopping on to the method 20 in here, that is min. Now what does the name suggest? It is basically going to return the minimum of the element that is present in this list. So we are going to store the minimum of L in a variable m and going to print it. So let's test this out, and there we go. Here -4 is the minimum element that is present, and that's why it is returning -4 in here. So talking about the time complexity, it is going to be O of n, as it is going to iterate throughout the list to find the minimum element possible. So talking about method 21, that is max in here, it is quite opposite to the method that we read in number 20. So max is going to return the maximum element that is present in the list. So we are storing the maximum element in the variable called m and printing the variable m in here. Let's test this out, and there we go. It is pretty clear that 45 is the largest number that is present in the list, and that's the reason 45 is getting written in here. So talking about the time complexity, it is basically O of n, as it has to iterate throughout the list to get the maximum element possible. So talking about the method join in here, which is also the second last method of the day, let's hop into it. So what does join method do? Join method joins the element of a list into a string using a specified separator. So here you can see the separator is whatever you assign inside the single quotes dot the method that is join. And what do you want to join in here? We want to join the list L. So that's how we are using the join method. Let's try to run this out. And there we go. It is clearly visible that it is saying subscribe to Bold Coding channel. So in case you haven't done it yet, do subscribe. Now talking about the time complexity, it is basically O of n plus m, where n is basically the length of list that we are passing into join method, and m is basically length of the resulting string. Now as we have to join the resultant string of the list, so we have to traverse throughout the list, and since we have to join it, we have to traverse word by word throughout the entire list, and that is the entire resultant word, and that's the reason why we are specifying time complexity as O of n plus m. So this is the last method of the day, that is slice method. So in case you have checked out my previous video, you must be aware of ways to produce a slice or get a slice from the original list. But here we are going to get a slice using the slice method. So here we are storing the slice inside a variable p in here, and we are storing the value at z variable, that is L of p, that is L of the slice, that is 3 and 7. And let's try to print what z returns. And there we go. It is returning the value that is present at index 3, 4, 5 and 6. Talking about the time complexity, it is very clear that time complexity is O of k, where k is basically the length of the slice. Now that we have completed all the methods of list, I hope you liked the content so far. In case you liked it, then do share amongst your friends and ask them to subscribe. And also, if you have some kind of doubts, suggestions or queries, feel free to reach out to me through my LinkedIn channel, comments of the YouTube or email. Bye bye guys, see you in the next video with such awesome contents.